Alright, this lesson is all about figures in the coordinate plane. We'll be taking our rectangles and squares and parallelograms and putting them on a graph and using our skills to prove what they are and special properties about them. Throughout this video, I'm going to be referring back to this handy-dandy set of notes where I've sort of outlined the key, the ones shown in yellow here are the definitions. For example, the definition of a parallel is that opposite sides the definition of a parallelogram is that opposite sides are parallel. Okay, the definition of a rhombus is that we have 4 congruent sides. The definition of a rectangle is that it has 4 right angles. Those are just some examples, but also for each one, in red here, I'm showing some special properties of that shape. Okay, for example, for all parallelograms, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, and consecutive angles are supplementary. So I've got some nice little handy-dandy notes for each one of these shapes. And so I'll refer back to them. Feel free to take notes so you can have these for yourself. Okay, let's take a look at the first problem. We have this figure shown here, and we are told that DG is parallel to EF. That's what that symbol means. These are parallel. And let's see, I can go ahead and indicate parallel with a little arrow like this, all right, to remind me that those are parallel. So we have one pair of parallel sides. So right away, that triggers my knowledge of a definition. If you have a shape that has exactly one pair of opposite sides parallel, that is a trapezoid. So that lets me know that we are dealing with a trapezoid. Now, the only question is it just a random trapezoid, or will it be an isosceles trapezoid? An isosceles is a trapezoid where the legs, the non-parallel sides, are actually congruent. All right, same length. So in this problem, they're asking what additional information would prove that this trapezoid is an isosceles trapezoid. So we know it's a trapezoid because we have one pair of sides parallel. Okay. So to prove that it's an isosceles trapezoid, we need one additional piece of information. We need to know that the legs are congruent. We need to know that this side and this side are equal in length. So that's DE and GF. We would need to know that those are congruent to each other. Okay, and that's the answer to the question. That's what we would need to know. Alright, let's take a look at problem number 3. You'll notice I'm doing the odds. Don't worry about that. Those numbers don't mean anything to you, but working through a list of problems and I'm doing the odds. So anyway, we're told that this shape is a parallelogram. Okay, now what additional information would we need to prove that this is a rectangle? So it would be helpful to take a look at the definition of a rectangle and perhaps the special properties of a rectangle. The definition of a rectangle is that we have 4 right angles. Now, it turns out if you already know it's a parallelogram, you don't really need 4 right angles. All you need is 1. Or if we knew that the diagonals are congruent. Okay, either one of those. So 1 right angle or congruent diagonals, that would prove that it was a rectangle. Okay. So as I scan down the list of choices, I'm looking either for 1 right angle or I'm looking for the diagonals to be congruent. I don't see anything about anything being congruent. Alright, so much for the diagonals. I do see this right here. I see 2 things being perpendicular, which means, of course, that means we're talking about a right angle. Alright, but let's see if we're talking about the corners. So we're talking about LP is perpendicular to PN. So here's LP, and if that is perpendicular to PN, that would mean that this is a right angle. So again, if you already know that it's a parallelogram, all it takes is one right angle to prove that this thing is in fact a rectangle. Okay, so there you go. That's why this is the answer to that one. All right, let's take a look at number 5. All right, we have this figure. Now, which statement proves that this parallelogram is a rhombus? So we're told it's a parallelogram, and we need to prove that it's a rhombus with one additional piece of information. So first of all, again, let's look at our notes and see what a rhombus is and what the special properties are. So first of all, the definition of a rhombus is 4 congruent sides. So if there were some statement where they were saying that each one of these sides equaled all of the others, all the sides are equal, then that would be good. So let's scan, does it, nope, nope, nope. None of them say that all 4 sides are equal. So much for the definition. What else? Now here's a property. Whoops, I'm looking at the wrong thing. Here's a property of a rhombus. The diagonals are perpendicular. So if there's a statement that says something about the diagonals are perpendicular, or something that allows us to know that the diagonals are perpendicular, then that would prove it. Okay? Because, yeah, if we already know it's a parallelogram, the only kind of parallelogram that has perpendicular diagonals is a rhombus. Okay, so let's look for that. All right, this one's about midpoint. Okay, that would be true for any parallelogram. This is nonsense. The slopes of these are equal, and they're also, that again, that statement just proves it's a parallelogram. That brings us down to this last one. This looks promising. All right, they're talking about KM. Okay, let me switch to pink for this. They're talking about KM. Actually, I'm going to do this. KM is a diagonal. Okay, is it too late to do the color on this? All right, I'm not sure it was worth all that effort, but there you go. So KM is a diagonal, and then they're also mentioning NL. And check it out, NL is another diagonal. All right, I'm just going to draw this by hand. So this statement is about the diagonals. Now remember, the property we were just looking at is that the diagonals of a rhombus are perpendicular, and it's the only parallelogram that has the diagonals perpendicular, would be a rhombus. So if only this said that the diagonals were perpendicular, then I would know this is the answer. Instead, it's talking about the slopes, and it's saying that one slope is 1 and the other diagonal has a slope of -1. What does that have to do with perpendicular? Well, in a previous lesson, we learned that slopes can tell you whether or not 2 lines are perpendicular. And let's go to the blackboard for a second. All right, here's what we learned. We learned that if we know that 2 lines, or if we want to know that 2 lines are perpendicular, okay, they will be perpendicular only if their slopes are opposite and reciprocal. So for example, if I know that this has a slope of -2/3, and if I know that the pink line has a slope of +3/2, then we know that these are in fact perpendicular because their slopes are opposite and reciprocal. Okay, 3/2, 2/3, one's positive, one's negative. So if they're opposite and reciprocal, you know they're perpendicular. So now let's look at the slopes that we have now. they're telling us that one of the diagonals has a slope of positive 1. So the question is, are they opposite and reciprocal? So what is the reciprocal of 1? Well, remembering that 1 is basically like 1 over 1. If you do the reciprocal, it's still 1 over 1. So the reciprocal of 1 is still 1. Okay, so 1 is a special case. It is the reciprocal of itself. So they are reciprocals. Now, if 1 is positive and 1 is negative, then they are opposite and reciprocal. That would make them perpendicular. And that's exactly what we have. We have positive 1 and negative 1. They are opposite and reciprocal. That means that these diagonals are in fact perpendicular, which would prove that this is a rhombus. So that means this last one should be the answer. Okay, take a look at number 7. We're given this figure. The triangle ABC is an isosceles triangle. So they're telling us that AB and AC are equal. Let's go ahead and mark that so we don't do more work than we need to. And now we're being asked to find the perimeter of triangle ABC. So we know that the perimeter means we need to find the lengths of all the sides and add them up. Now, luckily, one of the sides here is vertical, so that means we can just count this the length of this side. So this side is 1, 2, 3, 4, 5. Okay, so that side is length 5. Now, we're told it's isosceles, and we've marked these two sides equal in length to remind us. So that means these are both 5. That means all we really need is to find the length from B to C. Okay, now let me just blow that up a little bit because it might be hard to see. We have negative 1, 1, and then we have the point 2, comma 2. So we'd like to know how long that is, which is the same as asking what's the distance between these 2 points. I'm saying it that way because I'm trying to remind you that what we need is the distance formula. And we learned if you want to find the distance between 2 points, if you've got 2 points, x1, comma y1, and x2, comma y2. If you want to find the distance between those 2 points, then what you do is you do x minus x squared plus, and then you do y minus y squared. And you take the square root of all that, and that will tell you the distance between them. So if I want to find the distance from B to C, in other words, the length, and we can just call it BC, all right? When you write BC like that, it automatically means the distance between. Then that's what we will do. We will do the distance formula. Okay, so we're supposed to do x minus x. So I'm going to do 2 minus negative 1. Okay, 2 minus negative 1 squared. Now I'm going to do y minus y. So that'll be 2 minus 1 squared. Okay, now anytime you have minus and negative like that, I encourage you to remember that this is the same as addition. So 2 minus negative 1 is really just 2 plus 1. Okay, so you can do as much of this by hand as you feel comfortable with, and the minute you don't feel comfortable anymore, you can start using your calculator. Okay, so do what you feel comfortable with, people. But hold on, let me just do this real quick. Okay, so you are allowed to use a calculator for this if you need to. So I'm just going to demonstrate how you could use a calculator, even though, I'm a pro, so it's very easy for me to do it by hand and not make any mistakes. But you could put 2 plus 1 squared plus, and then you could put 2 minus 1 squared. Okay, so this should give us the distance. Boom! And that is the square root of 10. Okay, so the perimeter. Let me just change colors now. So if I want the perimeter, I have to add all these up. So I'm talking about 5 plus the square root of 10. So of course 5 plus 5 is 10. So this would be 10 plus the square root of 10. Now we can always make decimals if they want, but let's look at the answers and see if we need to do that. No, they've left it just like this. So hopefully you can see why this is the answer. I'm pretty sure this is number 9. Almost lost track. This is really the same as the last problem, so it should be super easy. Let's see. They're telling us that in the diagram AB is 10. Okay, so we know that this is 10. AC is 2 radical 10. Alright, so we didn't even have to do the distance formula. What is the perimeter? So the only side we're missing is this horizontal side. Because it's horizontal, I really could just count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10. For what it's worth, if you didn't feel like counting, you could subtract to find the distance. Okay, I could do 5 minus negative 5, and that would also give you 10. Or you could just count. Anyway, so we have all three sides, so that means that the perimeter, if I add these all up, 10 plus 10 plus 2 radical 10. I can really only do anything with these, so that's 20 plus 2 radical 10. So that should be the answer. Okay, and there you go. Okay, here we go with another perimeter problem. This time we have a trapezoid. Okay, but we don't know that it's isosceles or anything like that. But they were kind enough to give us 2 of the sides are horizontal. So that means we will be able to count for those. So here I have 1, 2, 3, 4, 5, 6 squares across. And up here I have 1, 2, 3 squares across. So I've got those 2 very quickly and easily. The other 2, however, I will need some distance formula. Alright, I'm going to need some distance on this. Okay, so I'm going to color code this so you can see it easily. So I'm about to do the blue side, MJ. Okay, and remembering the distance formula, okay, because that's all I'm about to do, I should do x minus x. Okay, the order doesn't really matter, to be honest with you. So I'm going to do negative 7 minus negative 8 squared. Alright, I did x minus x. Now I'm going to do y minus y. So I'm going to do 4 minus 3 squared. Okay, so that should give me the length of MJ, the distance from M to J. And I am going to use my calculator to help me out. My calculator is going to help me help you. Okay, so what it is, I'm going to do square root. Okay, negative 7 minus negative 8. I could have just put negative 7 plus 8 if I wanted to. Okay, notice how that's 2 different types of minus or negative. When I'm doing a negative sign, I'm using the little white one. When I'm subtracting, I'm using this gray one. So be aware of that. Okay, these are 2 different buttons on the calculator. Anyway, plus, open parentheses, 4 minus 3. So again, you can do as much of this in your head as you feel comfortable with. and use your calculator where your comfort runs out. Anyway, boom, that's radical 2. Okay, so that tells me that mj is radical 2. So now we need KL. So I'm going to switch colors. I'm going to go green to make it easier for you to follow what I'm doing. So I'm going to come over here. I'm doing KL. Okay, and again, I'm doing x minus x squared and y minus y squared. And again, the order doesn't really matter for this type of problem. So I'm going to do -4 minus -2. Minus -2. Make sure you get both of those in there. Minus negative. Okay, and now I'm going to have 4 minus 3. That sounds familiar. Okay, let's see what we get for KL. So I got square root -4 minus negative. I missed one. -4 minus -2 squared plus 4 minus 3 squared. Okay, so that is radical 5. Okay, so this is enough to tell me the perimeter. Okay, which I'm going to put, there's really no space for me to put it right here. The only two numbers I can truly add together are the 3 and the 6. 3 plus 6 is 9. So I know I'm going to have a 9. Now these other two are not like terms. You can't add radical 2 and radical 5, for example, and make radical 7. That doesn't work, all right? If I had 3 radical 2 plus 5 radical 2, that I could make 8 radical 2, but the radicand, the number under the radical, has to be the same. You can't do anything with radical 2 and radical 5. So I'm just going to leave it radical 2 plus radical 5. So this would be an expression for the perimeter. I'm not sure what order they'll go in, but let's look at the answers and see what we got. Oh, look, they did just like I did. Okay, kabam! There it is. That's all there is to that. Okay, let's take a look at number 13. The perimeter of this parallelogram is 2 radical 26 plus what? All right, so they're sort of leaving a blank here. Now we're told it's a parallelogram. So that tells us that the opposite sides will be congruent. That's one of the properties of a parallelogram. The first property I have listed here is that for all parallelograms, the opposite sides are congruent. Okay, so they've given us WZ is radical 26. Okay, so WZ is radical 26. That means that XY is also radical 26 because they're opposite sides. Now, the horizontal parts, of course, we can count. All right, that's 1, 2, 3, 4. And of course, up here, we already know it's going to be the same 1, 2, 3, 4. So we can add this up and see the perimeter. We've got 4 plus 4 is 8. And then radical 26 plus radical 26. Think of it as 1 radical 26 plus 1 radical 26. Hopefully you can see that'll be 2 radical 26. Okay, when I write it that way. All right, 1 apple plus 1 apple is 2 apples. Well, 1 radical 26 plus 1 radical 26 is 2 radical 26s. So this is the perimeter. So we have radical 26 plus what? Should be radical 26 plus 8. Okay, and that's why they're saying 8. All right, this will be the last problem, and it is one more perimeter problem. Now we're told that this is a rhombus, and we're being asked to find the perimeter. So don't forget about the definition of a rhombus. Okay, the definition of a rhombus is it has 4 congruent sides. It's a quadrilateral with 4 congruent sides. Okay, so we know that all 4 of these have to be equal. So they didn't give us any of them. So it does look like we will have to use the distance formula. But the good news is we only have to do it once, and because they're all the same. So just pick a side, any side. Let's see. I think I'll do AD. All right, I'm going to do this side right here. Okay, which means I'm focusing on these points as I do my distance formula. So AD should equal the square root of, now I'm going to do x minus x squared. So I'm doing -2 minus 1 squared, all right, x minus x. And now I'm doing y minus y. So I'm doing 5 minus 1 squared. All right, it's bugging me where I put that. Okay, that should give me the length of AD, which, because it's a rhombus, all 4 sides are congruent. They'll all be the same. So let's go. Okay, so this is going to be -2 minus 1 squared plus 5 minus 1 squared. Okay, and that's giving me 5. All right, it's fun when it comes down to a nice round number. So if that's 5, that means they're all 5. Okay, so because 4 times 5 is 20, the perimeter should be 20. Okay, and that's why the answer was 20. All right, I hope this tutorial was helpful, and good luck.